Why does a breathing problem end up damaging your heart? The answer starts somewhere you would never expect to look. Not your lungs. Not even your heart itself. Your gut. If you or someone you love uses a CPAP machine, you already know the basic story of sleep apnea. Your airway partially collapses while you sleep. Breathing stops, starts, stops again, sometimes hundreds of times in a single night. Your body panics quietly in the dark, jolting you just enough to breathe again without ever fully waking you. And doctors have long known this raises your risk of heart disease down the line. But here's the question nobody could quite answer: how, exactly? What is the actual chain of events between a breathing pause at 3 a.m. and a clogged artery 20 years later? In June 2026, researchers at the University of California, San Diego, presented an answer at the ASM Microbe conference that points somewhere almost nobody was looking. Not at your airway. Not directly at your heart. At a class of molecules made in your liver, stored in your gallbladder, and modified by the trillions of bacteria living in your gut. Those molecules are called bile acids. You probably think of them, if you think of them at all, as boring plumbing. Your liver makes them, your gallbladder stores them, and they get released into your intestines to help break down fat when you eat. That's their day job. But bile acids have a second job most people never hear about. They also act as chemical messengers, hormone-like signals that travel through your bloodstream and talk to receptors in organs far from your gut. One of those receptors is called the pharyngoid X receptor, or FXR for short. Think of FXR as a switch. Bile acids can flip it on or off, and depending on which way it's flipped, it changes how your body handles fat, inflammation, and, it turns out, how your arteries respond to the stress of sleep apnea. Here's where the researchers got clever. Led by first author Celeste Allaband, the team took two groups of mice already genetically wired to develop heart disease. One group had a fully intact FXR receptor. The other group had that receptor deleted entirely, deactivated on purpose, so scientists could watch what happened when the switch simply couldn't be flipped. Then they exposed both groups of mice to conditions mimicking sleep apnea, repeated drops in oxygen, the same kind of intermittent, jarring stress your body goes through every time your airway briefly collapses at night. The mice with a working FXR receptor developed exactly what you'd expect: fatty plaque buildup in their arteries, the same kind of plaque that narrows blood vessels and eventually causes heart attacks and strokes in humans. But the mice without FXR? They developed significantly less plaque. Not in every single vessel, some still showed a bit of buildup in the pulmonary artery, but in the aorta and the aortic arch, the major highways of blood flow near the heart, the difference was substantial. Deactivating a single gut hormone receptor meaningfully blunted one of sleep apnea's most dangerous long-term effects. That should surprise you. For decades, sleep apnea research has focused almost entirely on the mechanics of breathing and oxygen. Fix the airway, fix the oxygen dips, fix the downstream damage. That logic isn't wrong. But it turns out it's incomplete. So let's walk through what researchers think is actually happening, step by step, on a typical night for someone with untreated sleep apnea. Your airway narrows. Oxygen briefly drops, and carbon dioxide briefly rises, dozens or hundreds of times before morning. That repeated swing in your blood chemistry doesn't just stress your heart and brain directly. It also reaches your liver and your gut, altering how bile acids get produced and, crucially, how gut bacteria chemically modify them before they re-enter your bloodstream. Those altered, microbially modified bile acids then travel onward and interact with FXR, on and around your blood vessels. Activated in this particular way, under this particular repeated stress, FXR appears to help set off an inflammatory cascade that encourages fatty plaque to build up in your arteries over months and years. In other words, the damage doesn't start with a struggling heart. It starts with an oxygen dip that gets translated, through your gut microbiome, into a chemical message your arteries were never built to safely ignore. And here's the twist that makes this discovery matter beyond one lab's mice. The researchers didn't just find that FXR was involved. They found that removing it also protected the animal's gut microbiome and overall metabolism from some of sleep apnea's other disruptive effects. One receptor, sitting at the intersection of gut bacteria, liver chemistry, and cardiovascular disease, seems to be doing an outsized amount of quiet damage control, or damage creation, depending on whether it's switched on. Think about what that means for how we've been treating sleep apnea. For decades, the entire treatment conversation has centered on the airway, CPAP machines, oral appliances, sometimes surgery, all aimed at keeping that passage open so oxygen never drops in the first place. That approach genuinely helps, and if you have sleep apnea, using your prescribed treatment consistently still matters enormously. But this research points to something treatment guidelines have barely begun to consider: a second front, sitting not in your throat, but in your gut microbiome and your liver's chemistry, that may need its own kind of attention someday. The researchers are now doing exactly what good scientists do next, checking whether the same pattern shows up in actual human sleep apnea patients, not just lab mice bred for heart disease. If it holds up, it opens the door to something sleep medicine has never really had before: a treatment target that isn't your airway at all, but a specific bile acid, or a specific gut microbe, or a specific receptor you could someday adjust with something as simple as a modified probiotic. That's the quiet pattern showing up again and again in modern medicine. Two systems you'd never think to connect, your breathing and your gut bacteria, turn out to be having a conversation the whole time, one that shapes something as serious as whether plaque builds up in your arteries. Your gut isn't just along for the ride while you sleep. It may be helping write the story of what happens to your heart 20 years from now. So the next time you hear that sleep apnea is bad for your heart, you'll know it's not simply about oxygen going up and down. Somewhere between your collapsing airway and your hardening arteries, your own gut bacteria are quietly rewriting a chemical message, one your body was never designed to safely receive, hundreds of times a night, for years, without you ever knowing it was happening at all.